The town of La Serena. The nearby observatories make La Serena a natural stopping-off point for astronomers. Beyond the town, the land is sparsely settled by peasant farmers. In the foothills of the Andes lies one of the world's major observatories, Cerro Tololo. Observatories are worlds unto themselves, outposts in our quest to know the universe. Astronomers usually come for 2 to 5 nights on an observing run. The routine is much the same at observatories around the world. Sleep during the day, eat in the afternoon, and work all night. Tyson has come to Cerro Tololo for a 2-night run. Assisting him is Raja Guhathakurta from the Institute of Advanced Study in Princeton.
Okay, let's see, we've got 3 of these.
Tyson's search for gravitational arcs begins by finding places in the sky that appear empty.
I don't see anything interesting. Places where there aren't things like that. It seems a little strange for astronomers to do to look at places in the sky where there's nothing. But in fact, what we in fact found was that there were just lots and lots of galaxies in these rather tiny fields where there just happened to be nothing on these photographic plates. We found 1,000, typically 1,000 faint blue galaxies.
Galaxies are the building blocks of the universe. Usually they occur in clusters containing thousands of galaxies. Probing the darkness beyond the clusters, Tyson discovered that the space was not empty at all. There he found numerous faint blue galaxies. These galaxies provide a luminous backdrop, a curtain of light that Tyson can use to search for gravitational arcs. The light from the background galaxies will be bent by any dark matter contained in the foreground. This creates gravitational arcs, the fingerprints of dark matter.
Knowing that the sky is peppered with this backdrop of roughly 20 billion faint galaxies, we can use those faint galaxies as a tool to study the foreground dark matter.
Well, that's certainly a candidate, isn't it?
Yeah,
as is that one.
Astronomers make the short trip to the telescopes in a Volkswagen. Once they used golf carts, but when funding became available, the observatory upgraded. All the cars are of the same vintage, with the same mileage, and they rarely get above second gear.
Starting out in science, it was difficult in the local libraries to find any books on science. I found a little tiny thing once on linear accelerators, sort of a popularization of linear accelerators, and so I built one. The thing practically exploded. I think there were a couple of people that affected my vision of what I could do in science. And that was in the 6th grade. I had a teacher who encouraged science experiments. And then later on in high school, there was a science teacher that encouraged experiment and observe. Individuals make a difference. We should go into focus very soon. Well, Raja was a very good student, and he's I think, going to go quite far. He brings to the project a great deal of enthusiasm and also a very broad understanding of the astrophysics behind it.
Tonight, Tyson will use the largest telescope on the mountain. A reflector whose mirror spans more than 8 feet. Outfitted with the latest electronics, this telescope is one of the most powerful in the world. The control room of a large telescope resembles a flight deck, crewed by a pilot, a navigator, and a man at the helm.
I can move it down if you want. Thank you.
Astronomers seldom get more than a few nights of telescope use in a year, so observing runs are well planned.
Every second counts. This is a big telescope, and we get very little time on big telescopes. It's very highly competitive, and we have lots and lots of observing to do.
Tonight, Tyson will aim the telescope at several targets.
Okay.
Charts and star maps are used to navigate.
Yeah, I'll do that in a second.
Okay. This gives us a nice finding chart. It helps us find our way on the sky, if you like. I mean, by looking at the stars there and comparing it with what we're seeing now, we can tell whether we're in the right part of the sky or not.
To search for gravitational arcs, Tyson must meet two objectives. Image the background galaxies, then find a foreground cluster. If the cluster contains dark matter, Tyson should see gravitational arcs.
That's just about right.
To succeed, Tyson must look deep into space, pushing the telescope to its limits. A telescope is a time machine. Tyson looks back to a time over 12 billion years ago when the first galaxies were forming and the universe was emerging from darkness. Tyson's first stop is a seemingly empty region of space. The background galaxies are much fainter than the natural glow of the night sky. To distinguish galaxies from electronic noise in his detectors, Tyson jiggles the telescope. Eventually, the faint blue background galaxies appear. Now Tyson must find a foreground cluster. If the cluster contains enough dark matter, the light from the background galaxies will form gravitational arcs. Though dark matter is invisible, Tyson believes his technique allows him to create pictures showing its shape and distribution.
The most significant thing about what we're doing currently is that this is the first time that we've been able to actually see dark matter. We can actually image the stuff. And you get a picture of it. And these pictures, the way it appears on the picture, if it's clumped or stringy or just a nice little round blob, I think is going to end up telling us something about its nature and about the history of the universe and the way things eventually clump together under their mutual gravitational attraction.
Tyson records his images on computer tape. Only after careful analysis can he be certain he has detected dark matter.
I thought I convinced myself a few minutes ago that I could see some more blue arcs in this thing, but we'll have to wait for the data reduction.
Okay. Can you guide on that?
Through the night, they'll continue to work.